In our first technical lecture, we're going to talk about energy, which is the central concept in engineering. And since our course is focused on electrical engineering, we will steer the discussion towards electrical energy. Before we start, please answer yes to the following questions. You should pause the presentation when advised and do the activities. Let's go. Alright, so what is energy? It's the ability to do work. It can come in many forms. It's important to realize that energy is conserved, although it can change forms. It can take on the form of heat, light, electrical energy, chemical energy, mechanical, which you're familiar with, potential and kinetic energy. It can also take on the form of mass, as Einstein pointed out. Alright, so I would suggest right now to go to Wikipedia and pause the video and write down 3 cool facts that you didn't know from before. Alright, if you're coming back, I'll share the 3 facts that I wrote down after reading the Wikipedia articles. That Earth's core radioactive decay drives plate tectonics. Energy conservation is due to translational symmetry of time. And energy replaced the vis viva term of Leibniz. So the term energy used in the physical sense has only been about 200 years that it's been in use like that. All right. Hopefully your facts are, well, probably your facts are very different from mine that you wrote down. Okay, so one way to start quantifying energy maybe is to think about something with high energy that corresponds to something with low energy, to think in pairs. For example, a highly energetic person might be ready to kick some well, punching bags, kicking dummies. Hopefully not other people, as this guy on the left is clearly ready to do. If you have kind of low energy, maybe you'll just take a nap. All right. For me also, there is maybe a strong association of an electron at a higher energy level might go down to a lower energy level and emit a photon, or absorb a photon and go from a lower energy level to a higher energy level. Okay? But I would urge you to write down your own pairs that you experience, and sensibility allows. Okay, so please write down, pause and write down some pairs. All right, if you're coming back, we can start talking about what kind of work can be done if you have high energy or enough energy to do it, and we'll talk a little bit more about that too. You could drive to Chicago, move a couch, cook an egg, lift a camel, launch a satellite, stay awake and lecture, electrocute somebody, send an email. You can write down some of your ideas that would take energy, things that would take energy. Alright, so here's what I would like you to try to do. How much energy do the feats in the previous slide require? Okay, you can choose 1 or 2, try to do some research, estimate or calculate, whatever, but maybe come up with a number for 1 or 2 of them. You can leave your answer in joules, kilowatt hours, calories, it doesn't matter, kilocalories. You can easily find conversions among all the energy units. Alright. I totally realize that a lot of these seem very difficult to estimate, so think the stuff that you might need to know. Just try to make a step in the right direction. Okay, some of the feats can readily be accomplished using electrical energy, so you can think about what kind of technology you might use in order to do that. Maybe lift a camel with something like a battery-powered crane or something like that, or an electromagnet. I don't know, that's just one thought. All right, and we'll discuss some of these later. Thank you.